Hi, don't forget to check out my course for the quant section of the CAT exam where I've explained all concepts, tips and tricks, shortcuts and past year questions in great detail. Hi guys, let's look at the next question from CAT 2018, the first lot. Don't forget to pause the video and try it once before you look at the solution. Right, so the question reads, if f of x is equal to minimum of 2x square comma 52 minus 5x, where x is any positive real number, then the maximum possible value of f of x is. Type in the answer question. So we'll start by drawing our Cartesian coordinate system. The question says f of x is minimum of 2x square and 52 minus 5x. Let's consider two graphs. The first one being y is equal to 2x square and the second graph being a straight line y is equal to 52 minus 5x. We notice that the two graphs intersect at some point given here, and since this point is visibly in the first quadrant, x is definitely a positive real number. Now notice f of x is the minimum of these two graphs, meaning at any value of x, whichever graph has a smaller y coordinate is the value of f of x at that point. As an example, when x is 0, we have the origin. At that point, y is equal to 2x square will be 2 into 0 square or 0, whereas y is equal to 52 minus 5 into 0 will be 52. Between 52 and 0, 0 is lesser. So f of x at x equal to 0 is defined by this point 0. You will notice that before this meeting point to the left, y is equal to 2x square is always smaller than 52 minus 5x. So for all the points to the left of the meeting point, we will refer the graph of y is equal to 2x square for f of x. Similarly, y is equal to 2x square will go above 52 minus 5x if you go beyond the meeting point. So beyond this meeting point to the right, 52 minus 5x will have a lesser value as compared to 2x square. So in this case, 52 minus 5x is the value of f of x. So now we can conclude that f of x is nothing but this particular graph. I am highlighting this in green. This is your graph of f of x, the minimum of these two, as highlighted here in this particular case. But our question wants the maximum possible value of f of x. We can very clearly see here that f of x is maximum at this peak where the two graphs intersect. So basically I am looking forward to the intersecting point of these two graphs. The first graph is y is equal to 2x square and the second graph is y is equal to 52 minus 5x. This meeting point is our point of maximum as required. Guys, this meeting point has some coordinates, let's say x comma y. These coordinates x comma y are present, or this point is present on both the graphs y is equal to 2x square and y is equal to 52 minus 5x, right? So the next step is, let us equate the y coordinates of both these graphs. So we'll equate the value of y for both the equations. Basically, we are equating 2x square with 52 minus 5x. So the first step is to equate 2x square and 52 minus 5x. On simplification, this becomes a quadratic 2x square plus 5x minus 52. I want two numbers whose product is 2 into 52 minus 104 and the sum should be 5. Some knowledge of tables will tell you the numbers are plus 13 and minus 8. So I can break 5x as 13x minus 8x, right? So the quadratic now becomes 2x square plus 13x minus 8x minus 52 is 0. This simplifies to 2x plus 13 into x minus 4 is 0, or x is minus 13 by 2 or x is equal to 4. But minus 13 by 2 is minus 6.5, a negative number. The question says x is a positive real number in this case. So we ignore minus 13 by 2 and we only want one value of x here, that is x is equal to 4. We have very simply found out the x coordinate of the point of intersection of these two graphs. Now we want to find out the y coordinate. Very simply, the x coordinate 4 will satisfy both the equations 2x square and 52 minus 5x, or the x coordinate 5 is a part of both the graphs y is equal to 2x square and y is equal to 52 minus 5x. So now our next step is to substitute x is equal to 4 in any of these two expressions. Y is equal to 2x square and y is equal to 52 minus 5x. Any of these two will get the value of y, or f of x as required is 32, the answer to our question. You can find 2 into 4 square, 2 into 16, 32, or 52 minus 5, 4, 20 as 32. So the maximum possible value of fx, that is y, is 32.